Hey, hi. This is a lesson about repeating decimals. So in this case, for instance, it's the 12 is repeated, so it's 0.1212121212 infinitely, and that's the reason a line on the top for repeating decimals. So what happens now is the way this lesson is done is repeating decimals all over, trying to figure out the various questions for repeating decimals. And so I do see that this one needs a repeating line on top of 3. I'm not sure, so we need to find that out. But these are the kind of questions that can lead to repeating decimals. The greatest transition from the repeating decimals lesson to that says round to the nearest thousandth, and that's probably the reason this is not. There's no line on the top. But the greatest thing I like about this is the way this lesson leads us to what is actually exponents. So this lesson literally leads us to what is exponents. That's the most fascinating thing I liked. And then of course these questions are very, very intuitive. So this is give the example of a repeating decimal where 2 digits repeat. Explain why your number is rational. So in this he says this is rational because it can be written in the form of A by B. So this is a form A divided by B form, which is a rational number. Then the next question asks you why any rational number is either a terminating or repeating decimal. So in this, he's replied, this is because any rational number can be a fraction and all fractions are terminating or repeating decimals. The last question is probably just brilliant to transition to an exponent lesson. And the question here is compare 0.1 and 0.1 and 0.1 repeating, or 0.13 and 0.13 repeating, and 0.157 and 0.157 repeating when written as fractions, and then write an explanation about expressing the repeating decimals like these as fractions. So the explanation he's given very accurately is using this information that the terminating decimal, the terminator is 10 raised to 9, which is the terminating decimal. For the terminating decimal, the explanation is 10 raised to 9, 10 raised to n, which is right. So it could be 10 raised to 1, 2, 3, 4. And the repeating decimal, the denominator, here the denominator, we're talking about denominator, right? Because obviously the numerator could be anything. So the denominator in the repeating decimal is 10 raised to n minus 1. And that's intelligent because this 10 raised to n would lead you to a lesson about exponents. So the explanation for the first one is 1 divided by 10. And for the repeating, it would be 1 divided by 10 minus 1. For 0.13, it will be 13 divided by 100, which is 10 raised to 2. And the denominator for repeating would be 13 divided by 10 raised to 2, that is 100 minus 199. So it would be 13 divided by 99. That's the end of my lesson. This is about decimals, repeating decimals, and terminating decimals, and then moving on to an exponent lesson. See you later with an exponent lesson. Thanks, bye.